All right, so let's go ahead and get started talking about angles. So an angle is formed by two rays that share a common endpoint. Okay, the common endpoint is called the vertex. So over here in our diagram, this point right here where these two rays meet, that's my vertex. Okay, the two rays are called the sides. So when you're looking at this, you have this ray right here, so ray BA, be considered a side, and this ray here of ray BC will also be considered a side. Okay, we usually name an angle by 3 points, so in this case it would be angle, and then you always start with 1 point, so I'm going to start here, so A, and it's kind of like connect the dots. You're going to go from A to B to C, so A to B to C. Okay, sometimes you can use a single letter. We don't use that often, but you can. And if you're ever referring to a measure or a value for the angle, they use this lowercase m in front of the naming convention to tell you that it is. And there are 4 types of angles. You have an obtuse, an acute angle, which means that your angle is between 0 and 90 degrees. Okay, you have an obtuse angle, which means that your angle is between 90 and 180 degrees. You have a right angle, which typically a right angle has this box in it. That means that it is 90 degrees exactly. And then you also have a straight angle. A straight angle. And if you have a straight angle, it means that your angle is 180 degrees. Okay. Congruent angles mean the exact same thing. That means that their measures are equal. So the measure of angle A is equal to the measure of angle B. Remember, if we're just writing it as being congruent, we say A is congruent to B. Yeah, that means angle, they're the same measure. Okay. An angle bisector is a ray that divides the angle into 2 congruent angles. Okay, so in this case over here, we have this ray here, ray BD, and ray BD, what it does is it takes this angle, this big angle, and splits it into 2 smaller ones so that this small angle of angle ABD is congruent to this small angle over here of DBC. And we know that by these 2 little mini parabolas in there. Those tell us that the angles are congruent. Right? Just like in the segment addition postulate, we have the angle addition postulate. Okay, so just like this, you have the smaller angle, so I named that 1. Okay, that angle is referring to this angle here, which is angle ABD, plus the second smaller angle, which is this here, so angle 2, which refers to this smaller angle of angle DBC. And that's going to equal our big huge angle, which we call angle 3, which would be this outside one, which is ABC. Okay? So, let's go ahead. The next 2 examples come from the worksheet that you got in class. Okay, so let's go ahead and start this. All right, so it says name the vertex of angle 4. Now, angle 4 is this tiny angle in here. So the vertex is the middle point right there. So that would be point B. Okay. The sides of angle 1, so the angle 1 is here. The sides would be the 2 rays. So that would be this ray right here. So ray BC. And this ray over here, which is ray BD. Remember, when you're doing a ray, you always have to start with the point that has no arrow, which in both of those cases is B. Okay. Angle 5, write another name for it. Remember, another name is using the 3 letters, so there's actually 2. You can go from D to B, so angle DB to E, or you can reverse it and say angle E to B to D. Okay. They want me to classify each angle, so angle F to B to C. So F to B to C is right there. Okay, and if you look down here, you see that this says BF is perpendicular. That means that it forms a right angle. So that means that this is a right angle. And we're going to talk more about perpendicular lines later on in this unit. Okay. The next one they want me to identify is angle EBF, E to B to F. That's clearly more than 90, so that would be obtuse. And the last angle they want me to find is angle ABC. ABC is just a straight one, so that's a straight angle. Okay. Name an angle bisector. Remember, an angle bisector is an angle that, or a line, a ray that cuts an angle into 2 congruent parts, and you look for these markings right here. So those are congruent, so that means that must be my angle bisector. So it's ray BE. Okay. For letter H, it said if EBD, E to B to D, is 36 degrees, and D to B to C is 108 degrees, how much is E to B to C? So just add the two numbers together, 108 plus 36, which gives me 144 degrees. And then lastly, okay, they gave me that E to B to F, the whole thing is 117. Okay, they want me to find A to B to E. But remember, because of this statement down here, this is 90, so we're going to do 117 minus 90, which gives me 27 degrees. Okay. Last example, using angle addition postulate to figure it out. Okay, remember our 1 plus 2 equals 3. Small plus small equals big. So here's my first small angle, and if you actually write it down, it's angle E to F to H. Well, they tell me that E to F to H is 5x plus 1, so that's angle 1, plus the other small angle here, which followed on H to F to G. They tell me that H to F to G is 62. And then the third one is always the biggest angle, which is the outside one of E to F to G, which they tell me is 18x plus 11. Okay, so we're going to solve from there. Okay, first I'm going to combine like terms. It gives me 63. Just add them together. Okay, then subtract your 5x from both sides. 63 equals, that's going to give you 13x here, plus 11. Subtract 11 from both sides. So they give you 52 is equal to 13x. Divide by 13. And you get x is equal to 4. So we found x. Okay, but then they want me to find EFH. So go back up here. Remember, EFH is this one right here. So EFH is 5x plus 1, which means we got to replace x with 4. So that's 21. And E to F to G, that's the big one. So they tell me that's 18x plus 11. So it's 18 times 4 plus 11. So 18 times 4 is 72 plus 11 gives me 80.